This is Rally Round the Cannon, some thoughts on Princeton's history by somebody who should know better. So they've just proved there's water on the moon. This is fascinating, in part because Professor Harry Hammond Hess of the graduate school class of 1932 knew there was water there, and he knew it 50 years ago. He was the esteemed chair of the National Academy of Sciences Space Science Board when we landed on the moon in 1969. Earlier in the decade, as the idea had surfaced about sending real scientists to the moon along with the jet jockeys, he was not only one of the instigators, but one of the first seriously suggested as a candidate. To understand how extraordinary he was, consider that he would have been 63 at the time. You might also want to keep in mind, this wasn't his day job. Until Harry Hess revolutionized them in 1960, the geological scientists were something of a 20th century afterthought. Darwin had biology zipping along, Freud had essentially invented his own scientific branch, Einstein sent physics leaping ahead, perhaps too far, Crick and Watson and their double helix turned biochemistry toward unrecognizable possibilities. There was the transistor and the computer, but rocks were pretty much still rocks. Not that there hadn't been glimmers. German Alfred Wegener in 1912 posited the seemingly ridiculous theory of continental drift, but nobody picked up the mantle, so to speak. So the idea that the massive continents were somehow moving across the world's seafloors was treated dismissively. The single resulting conference on the subject in the United States was expressly held to oppose the idea. Harry Hess was in grad school at Princeton when Wegener died in 1931, and not a lot happened publicly in geology while Hess literally marshaled his forces over the next 30 years. His dissertation led him to submarine seafloor exploration in the Caribbean in the 1930s while teaching at Princeton. His badgering of the Navy captains to order depth changes for readings led the Navy to make him a reserve lieutenant so he could just do it himself. So it was as a naval officer on December 8, 1941, that he hopped on the train to New York in his only uniform for what became 4 years of naval duty. Sort of. After using his precise scientific mind to help predict the routes of German U-boats in the Atlantic, he made for the Pacific, where he was given command of an attack transport ship. Not by coincidence, he made sure it was equipped with gear for sounding the ocean bottom. While he did see quite a bit of action, including 4 landings on Japanese-held islands, he saw even more of the Pacific floor, mapping almost 250,000 miles of it, ostensibly under orders, by the end of the war. Among other discoveries, he detailed curious mountains more than a mile beneath the sea that had been worn flat by wind and rain. Although unable to explain them adequately, he knew something important when he saw it and gave them a special name. They were geos, in honor of the great Arnold Geo, founder of the Princeton Geology Department and namesake of Geo Hall. Harry Hess emerged from World War II more knowledgeable of underwater geology than any other scientist on the planet, and it paid off. While remaining a captain in the Naval Reserve, he re-involved himself at Princeton with verve. By 1950, he had succeeded his mentor Arthur Buddington as geology chair. In 1952, Hess was elected to the National Academy of Sciences, along with no less than Princetonians Lyman Spitzer and John Wheeler. His well-developed administrative skills brought a deluge of roles beyond his department chairmanship. He was promoted to Rear Admiral, apparently a first for a Princeton alumnus. He was on the Princeton Committee of 3. He was on the faculty committee that helped select President Goheen. He served terms as president of 2 sections of the American Geophysical Union, the Mineralogical Society of America, and the Geological Society of America. His analogizing of apparent moon geography to Earth features and geologic processes earned him an increasingly responsible spot in space science, and he was sure there was water under some of the bulges on the moon, although his occupational focus back here was increasingly underwater. By the mid-1950s, he had Princeton grad students scouring the Caribbean for every worthwhile geologic feature they could dredge up for a dissertation, enriching his vast knowledge of the peculiarities of the seafloor. It was much younger than most land masses. It had different geologic structure and precipitous drops that seemed very problematic. Geos near the trenches were tilted for some reason. At some point in the late 50s, in the midst of all his activities, the overarching answer to the seafloor problems, and much more, came to him, although he never recalled how it did. New land was being created by molten upheavals along the fresh ridges beneath the oceans, in turn pushing existing land toward the deep trenches, where it eventually ground its way beneath adjacent land masses. The effect was the entire surface of the Earth being composed of 20 or so huge crust plates, arising from the ocean bottom and diving beneath adjacent plates, but always on the move. The geos, long previously above the water surface, were inexorably on their way down to a subterranean fate in the trenches, and the continents, which had indeed once been a huge single mass, were drifting in various directions on top of the plates. This description of seafloor spreading and plate tectonics, first reduced to writing by Hess in a paper to the Navy in 1960, is a stunning explanation for Wegener's continental drift, seismic fault lines, volcanic clusters, and many other geologic phenomena that has now reigned effectively unchallenged for 50 years. In many ways, it's so overwhelming and pervasive that those of us who have grown up since can't imagine it took so long to identify that our parents had no sense of the plates. The synthesis of the powerful idea is a piece of simple beauty on a level with E equals mc squared or the DNA double helix. Harry Hess, a lifelong chain smoker, died of a heart attack at age 63 in Woods Hole at a triumphant meeting of his space science board only 1 month after the first manned landing on the moon. He was in charge of distributing many of the moon rocks, but didn't live to analyze the one in his own lab. The Princeton faculty's resolution at its next meeting addressed the magic of his approach to geology. With all it said, Harry Hess had a deep, almost a religious reverence for the awesome order of the universe. He possessed that combination of driving urge to discover truth and a profound humility before the vast truths yet unknown, which is the mark of the truly creative scholar. The music of the spheres indeed, or at the very least, the age-old hymn of the plates. Yours in virtual orange and black. This is Greg Lang of the Great Class of 1970. Rally Round the Cannon is a podcast from the Princeton Alumni Weekly online.